Okay, so I realized yesterday evening that my slides were in German and the talk is supposed to be in English. So some of the jokes may be missing due to translation. I'm sorry. So basically, are we there yet? I'm, like most of you, apparently an IT security consultant. Usually I do source code audits, so you show me the source code, I show you bugs. But I would really much more like to do architecture review because usually it's too late if there's source code. Then all the bad decisions have already been done. Before we start, I have a little something to celebrate today. Someone emailed this to me 3 days ago. So it turns out in some Russian malware, they found my libc. So I'm guessing that's a great endorsement. You know, if you want it to really work reliably, you go to my libc. Anyway, the core question in this talk is, we spend so much money on security, why isn't it working? Right, so it's a keynote, so it's not too technical, but I usually like to do tech talks. So I hid a little tech talk in here. Maybe you can find it. So the answer is unfortunately quite easy. You're doing it wrong. It's possible to do security right, but it's not just buy products and be happy. So I've given variations of my advice talks for years, and usually people come to me and say, well, we didn't have time to do it properly. And so I looked up this inspirational quote that I think applies. You have all the time you need. You have just enough time, just as much time per day as all these important people and as me. So this talk will be about what I did and what the industry did. But let's play a little warm-up game. So it's an older meme. It's called How It Started, How It's Going. Let's do a demo round. Watson is revolutionizing industries. And how it's going would be whatever happened to Watson, right? So this is just so you have seen the pattern. There's another one. CrowdStrike wants to use AI, and how it's going, well, we don't know yet, but we have a pretty good idea, right? So that's the pattern. Let's play some Minesweeper. This started as a hunch, really. I promise you I haven't selected any of these manually. I just grabbed somewhere. So let's see. Take a few Gartner recommendations and see how it went. So first discipline is a firewall. How it started, quite easy. You go to Gartner, go to the review section for firewalls in this place and look at the first one. And the first one is Fortinet. Right, so go to the Fortinet webpage. Oh, it's next generation and it has a hybrid mesh firewall, whatever that is. And they all go the same, basically, right? Most of the examples I found are from this year, but you can go back to other years, it's the same thing. Right, so let's extend the pattern a bit, because usually people go, well, you have it easy, you just point at others. So what have I done? I don't have a firewall. My company doesn't have a firewall, we just don't have any ports open. So next discipline, endpoint protection. It started the same, we go to Gartner, see what they recommend, Trellix. Okay, revolutionary threat detection. And the same thing, right? So this is a local privilege escalation through the agent updater, which is exactly what this thing was supposed to prevent. And the whole industry is like that. But people, for some reason, tend to overlook it. Well, you probably saw this one coming if you follow my blog. I don't use any endpoint protection. I think it's snake oil. Next one, password manager. Yeah, you can probably see where this is going. Gartner recommends LastPass. If you followed the news, well, this is the homepage. Actually, it's quite funny because when I went to take a screenshot of the homepage, I got this pop-up. Strategies for combating compromised credentials. why would you need that? Because LastPass is supposed to protect from that, right? So it turns out there was a little hack last year that turned out to be a little worse, and then even more worse. And these are all still the current recommendations of Gartner. I didn't go to the archive and look what they recommended this year. This is what they recommend now. Right? So what I'm doing, I'm just using PubKey authentication, so I don't need a password manager. Okay, but the trend isn't passwords, it's multi-factor, right? So let's look at multi-factor authentication. Same process, we go to Gartner. Gartner says Duo. Duo has been bought by Cisco now, so it's more serious. And you didn't even need a compromise for that. If you look at how it works, you go to a server, you want to log in. The server goes to the cloud opens a pop-up on your phone, and you say yes. And then the cloud tells the server, okay. But if you look closely, steps 2 and 3 were optional. The cloud could just say, okay. So it comes pre-owned, basically. It's a miracle to me that people buy this stuff. Yeah, I didn't need that because I'm using PubKey and that's already 2 factors. So the CM is another one. This won't go on for too long, but I'm trying to make a point here. How started the CM stuff? Well, I looked around a bit. I think Splunk is the market leader. Well, funny enough, everyone is the market leader. If you look at the ads, everybody is market leading. And it's going to make your organization more resilient, they say. Unless you use the deployment server, then it's not so resilient. And you might wonder, well, you need access to the deployment server as an attacker. How would they do that? Well, turns out they didn't look at the TLS hostname. And these are the market leaders, right? I mean, it's not small companies. I'm not making fun of the little guy. These are the biggest companies in the business. Yeah, I'm not using Zeems either because they are attack surface. Last one, patch management. So it started pretty easy. People threw around graphs like this. You scan for vulnerabilities. I take offense from that because you should install patches always, immediately. Don't wait for vulnerabilities or a scan. That's just not a good idea. But as time went by, the flowcharts went bigger. And if you ask an admin in a big organization to follow this, it's not going to happen, right? So how it's going, this is in German. It's a podcast at the state radio. And it's about Germany's first cyber catastrophe, which was Bitterfeld. It's a community in East Germany, and they got ransomware. And it was so bad that they declared emergency. And they called the army to help install Windows. It was pretty funny, actually. So what do I do about patch management? I install all the patches, and you should do. This is the only way to go, really. This is a separate talk about this. I'm not going into details here, but so clearly something is not good. Actually, I don't know if you can see the details here. It says snake repellent granules, and I think that's a good picture to illustrate IT security products. Usually you're trying to follow some kind of best practices from the security industry, and the best practices usually involves buying some product. And it's not working, so we should do something. And I'm going to recommend what I did, because it works for me. So you may have noticed I had some time on my hands because I didn't have to clean up after all these crappy products that I didn't buy. So what did I do with my time? I set out and said, well, I want a blog, so I'm going to write software now for the blog. So first thing, I'm a pretty old school guy. I wanted a requirements list, so I said, well, it needs to show some static content, mostly static. A search function would be good. I don't need comments. That's more trouble than it's worth. So you start, as anyone would start, with the regular web server, and maybe you have the blog as a plugin, like a DLL shared library to the web server. That's how you could do it. And I thought, no, I shouldn't do that, because then if there's a bug in my blog, then they can read from memory the TLS key. That wouldn't be good. So the blog runs with a different UID than the web server. Pretty easy stuff so far. Now, I didn't want to insult anything, so it's a neutral headline, but you could read this as what you did, right? So I'm contrasting what I did to what occupied your time and why you didn't get to doing anything that's actually improving security. The IBM Cybertruck is a great example for that. So what do I do? First thing is, well, where's the content? I could just put it on disk in files. That's unprofessional, right? So I could use some SQL database. I decided to use an LDAP server that I had written for an unrelated project. Let's use that. This is actually a photo from an airport. I think it was Jerusalem, a couple of years back. It says, trusted full spectrum cyber across every domain. I think that's pinpoints what the industry is doing. Doesn't mean anything, of course. So why would I write my own LDAP server? Mostly because it's much less code. And my end goal is to run a service that I can trust, which means I need to have looked at all the code in the service to see which one is trustworthy and where I need to do more. And I found it quite stunning how big the difference is. You can see this like 2 orders of magnitude. So that doesn't mean that my LDAP server is more secure than Postgres. Not right off the bat, but it means if I want to make sure it is, then with my LDAP server, it can be done. But if I start reading Postgres tomorrow, I'll be dead before I'm done. Right? So all in all, the code size is quite small. It's just below 5,000 lines of code. And that includes the unit tests. And during that time, the industry was doing the value of leveraging full spectrum cyber to neutralize enemy threats. So Northrop Grumman is an arms manufacturer. So that's why this looks very military. Like that's exactly what they are. They build bombs. Okay, so I kept thinking, if someone hacks the blog CGI, then they can open any file, basically, that the CGI would have access to. So I should do something about that. And the industry looked at vulnerability management. I don't know if you know what that is. You don't need that. So my next thought is, well, okay, so I can prevent the open syscall, which is used to open files. But I need to do it myself. I need to open files. So I could first open the files I need and then prevent further opens, and then look at the input that comes from the attacker and could hack me. This is an old idea. For example, Ping uses it. First, they get the special socket, the raw socket, and then they drop privileges. Right? So this is what I'm proposing here. I'm dropping the privilege to call open. But only after I did the opens I needed. That's how you approach that. And the industry, I love these images. I spent some time collecting these. If you have any great images like these, just send them to me. Keep them coming. So it makes absolutely no sense. You see this uploading bar with 3.2 petabytes. What? Okay, so if someone hacks the blog CGI, they could also see logins from other users that happen while the attacker controls the blog CGI. Right? That would be bad. So I could use one process per request. So actually CGI, not fast CGI. One process per request, and then I could use seccomp, which is like a firewall for syscalls, basically, to disallow further ptrace. And ptrace is the syscall you would use to debug another process. So if you want to read the memory with the password from another user from a different process, you can either use a /proc/something, which is open, which I prevented already, or you can use ptrace. So I put every request in its own process and disallow ptrace. And the industry had this comprehensive study on cyber threat intelligence platforms. So, I mean, it's not like all the security experts twiddled their thumbs. They had lots of stuff to occupy them. It's just not useful. And I'm going down that rabbit hole, right? So the next thing is, okay, the attacker can still circumvent any access control I have as code in the block CGI if the attacker takes over. So don't do it then. Do the access restrictions in LDAP and not in the block. Right, that moves the problem. It's not solved, it's moved. But the block is now basically harmless. If an attacker finds a bug in my block CGI, they can do exactly what they could do before. So the attack makes no sense now, right? This is what we want. So I'm starting to feel a bit like a Bond villain here because I'm going down this string, and the attacks I'm considering are getting more and more esoteric. But bear with me. While I did that, the industry talked about threat intelligence. It's like a very current thing. It's absolutely worthless. Don't waste your time and money on that. It's just, it binds human resources you could use to do actual good work. Okay, so next target, let's say someone hacked the blog, and then from there hacks the LDAP server and gets code execution in the LDAP server. They could then watch other logins, right? Just the same. So I'm doing the same thing I did in the blog in the LDAP server. It's different processes, and ptrace is prohibited. So even if you manage to attack the LDAP server, you can see the credentials people give the LDAP server. And the next threat was attack path management, which is also useless. Don't do that. So the LDAP store does contain passwords because it checks against them. So if someone hacks my blog and then from there the LDAP server, they could see the passwords. So best practice is not to store the passwords by the hashes. So I'm doing that. And I make sure the complexity is high enough that it makes more sense to mine Bitcoins than crack my passwords. Yeah, it's getting worse and worse. I'm not commenting on these anymore. But I'm showing you that all the time I spend on thinking about how to secure my little blog, all that time you would have had too. It's not, I'm not, 100 years old. So all the time I spent, you could have spent. Right? This is what I'm trying to communicate here. So I'm still considering that an attacker attacked the LDAP server through the blog. What could they do? They could do the ransomware thing, right? They could encrypt my files. And my decision was to make the actual data store read-only. It's a file that is a binary format that has an index, so you can search in it quickly. And the tiny LDAP process can only read it. File system permissions allow it to open for reading and nothing more. And if somebody wants to write something, it's appended to a journal. And with seccomp, I can make sure that the only open call allowed has the O_append flag, which means you can only add stuff at the end, which is harmless to the binary that the file system permissions restrict to read-only anyway. And it means the attacker can corrupt old stuff, can just add corrupted stuff at the end. Which means if someone posts stuff to my blog, I can just cut it off and it's undone. This is a very powerful, complex idea, append-only data storage. And of course, it's helped in my example because I write very little to the blog compared to how often I read from it. But it's possible for many scenarios, not for the database in your organization, but for little things like the account database. It's very possible to do this. Nobody in the industry considers this kind of stuff. They invent new words like cybersecurity, mesh architecture, and identity fabric, whatever that is. So for this to work, the append-only data storage, I need to make sure that the moment when I integrate the changes in the journal to a new version of the binary database, that nothing corrupted survives. So in my blog, I have post a few articles a day maybe. So I do this manually out of bound. It's not a cron job. I have to do this manually, otherwise someone could sneak something in, right? So, okay, basically more of the same. So the attacker can still write garbage into my blog. That's still bad. But I can undo that by cutting off at the end of the journal. So I can sleep well with that. If there's like a night where some garbage was in my blog, then that's okay. My final goal, of course, the best achievement would be if I'm not hackable at all. But the way I'm going down, I'm happy with if I'm hackable, I can undo it, and I have time. So I think this is the most important thing you can do as a security department in a company. You can make sure that you take the stressful jobs now and not when you detected an attacker in your network. Because then the CEO of the company will be sitting behind you, breathing down your neck. You want that stuff done now, so in the time of crisis, you can respond easily. Okay, so let's say an attacker manages to hack my blog and then the LDAP server, then they could write an exploit into the journal that hacks the next instance of the LDAP server. I hope you realize that this is quite preposterous, this attack chain I'm proposing here. But if you follow this method and you just go down all the attack ways you can think of, you end up with this kind of preposterous attack. And that's good. That means the other ones don't work anymore. And indeed, I don't have a good answer to this. That means the journal reading code in TinyLDAP is prime attack surface, and I need to treat it as such. Needs to be audited well. But that's a tiny fraction of the code in the LDAP server. I can audit that several times and give it to friends to look at. I can actually recommend this to everyone. Just go around and collect screenshots of absurd IT security ads. So these guys say they can contain within 3 seconds a DDoS mitigation and have same-day blocking of 0 days. Sure. So what if someone hacks the web server? That's still bad. That's still bad, and there's not much I can do about that. That sounds like defeat, but it really isn't, because the web server is just one of 3 components, and I removed 2 of them, mostly out of consideration. So this is the stuff that I should be worried about. That's an insight you should have too. Because if you get hacked, if you know which components are safe, you can focus on the other ones. That speeds up finding out what actually happened. Right? So the web server is still a problem. I have some ideas. But if someone manages to get code execution in my web server, they can see all the traffic going through, and they can see my private TLS keys. And that's obviously both pretty bad. So I could do a privilege separation thing. I thought about that. I could move the SSL handshake in a different process. OpenSSH is something like that. But I know only one company that tried to do this for OpenSSL, and it's a major undertaking and the code's not public. But you could do it though. And it's on my list. However, if you move OpenSSL in a different process, most of the bugs, or basically all of the bugs that would have hit me, were in the OpenSSL part. So I'm not really gaining that much, because if you attack then the separated OpenSSL part, you can still see my TLS key because it's in memory. Right? So there's sometimes you hit a wall eventually and you go, well, I don't know how to fix this. But at least I have clarity what my walls are. And, okay. Why haven't I done that yet? Mostly because what I just explained. I put this in numbers here. Gatling is my web server. If I link a version with SSL support, which OpenSSL in this case, it's more than 95% of the end binary is actually OpenSSL. So, I could still have bugs in my code, obviously, but I'm really concerned about those 95%. Okay, so I left something out. I know what you think, and you're right. What about kernel bugs? So there are a couple of kernel bugs every year in Linux, and those are a concern, obviously. However, they are usually exploited through some rare syscalls. For example, most recent one that was really bad was stackrot, and they need to call membarrier. And I told you I'm using seccomp, which is a syscall firewall, basically. And of course, I'm using a whitelist. It's not a blacklist. So all of the syscalls basically you would use to abuse any of these or exploit any of these kernel bugs, you can't do from the seccomp firewall. It's already removed. So I'm not very concerned about kernel bugs. There could be one, for example, tomorrow that is in mmap, and that would hit me. Sure, it can happen. But there actually were some in mmap, and to trigger them, you would need it to open a few threads. And that's the clone syscall, which is also removed. So even kernel bugs, where most people go, well, if a kernel bug happens, then we're all fucked. No, not really. You can come up with plans against that too. I have a little confession to make. I'm a bit of a troll sometimes, and in this case, the blog design is not just about security, it's also about trolling the maximum number of people. So I wanted to troll the security people who say the C programming language is the most insecure. Don't use it, so of course I'm using C. I wanted to troll the Java people who say you need multi-threading for performance. I'm doing fork and exec for each request, twice actually, once in the blog and one in the LDAP server. So it shouldn't perform at all, but it does. I want to troll the database people. I have no caching, no connection pools. And I troll the perf people because I'm still faster than most of them. So it's not all about security, but you can have perf and security. It's just effort. You need to spend some effort. So let's revisit my methodology. So first, I make a list of all the concrete attacks that I can think of. The list can be very long, it doesn't matter. You just have to have a list. The idea is to have the developers make the list, not the documentation department, not the management. The developers, you want the developers to think about their product from the perspective of how would someone attack this? Right? You make this list and you go through the list, and for everyone on the list, every instance, you say, can I prevent this? If so, how? And step 3 is you just do what's necessary to prevent the attack if it makes any sense. Sometimes you can't, but that's okay. That's a risk then. Some risk will remain. So this is called threat modeling. It's a little dumbed down. There's more to threat modeling, but not that much. You should try this. It's good. Do this in your organization. There's a separate talk about that. It's a bit more than what I'm saying here, but basically do this and you will be much better than you are now. So what was my optimization criterion? I wanted to reduce the code that could bite me in the ass. You look for code that is dangerous and that would be worth attacking, and that's usually code that runs at a higher privilege than the attacker is. And the most critical code is the one that makes security guarantees. So the kernel is always dangerous. But if I do password checks and rule-based access control in my code, then that code is dangerous too. So you try to identify the code that is really dangerous to you, and you try to get rid of it as much as possible. You call that code attack surface. Right? So in my case, the LDAP server is less than 5,000 lines of code. The block is very small too. But even if the block was much bigger, I removed basically all of the risk from it. I could give you remote code execution in my blog, and you couldn't do more than you couldn't do now. So that's what we want. If we can achieve that, that's the goal. But it's not always possible. In this case, it was possible, so I did it to show you it can be done. My web server is also pretty small, but it links in OpenSSL and zlib. Those have bugs every now and then. And until I find a replacement that's more trustworthy, I will have to patch immediately. So this doesn't get rid of all the risk, but it gets rid of so much risk that I can sleep soundly at night. This is called TCB minimization. TCB is the trusted computing base. That's the code that's dangerous. And if you minimize it, if you can pull components out of the TCB, then you win. That's the goal. Note that the block CGI is no longer in the TCB, and Tiny LDAP still has some risk, but I can undo breakage. There's no way you can ransomware me through Tiny LDAP. So that's very good. That's almost out of the TCB. If you compare that to the industry standard, you will find it's a completely different optimization. The platform decision is usually done by management without even understanding the problem. It's like a golf course thing, or metaphorical golf course. Maybe it's gentleman's club. I don't know. Usually untroubled by expertise in the area or a risk analysis. That's how you should approach that. If you have a list of options, see which one is less risky than the others and do that one. Unless you want to troll someone, then you can have a little more risk, obviously. So then I usually see a big diffusion of responsibility. There's different layers of management and nobody is really sure who's responsible for what. That's by design. That's not an accident. That's what everybody wants, that if something bad happens, they can point at other people. Then you can put some snake oil on it, like endpoint protection, whatever, ZIEM. This is part of the diffusion of responsibility, because then you can say, well, we did everything right, but the vendor should have protected us, and they didn't, so it's not my fault. But it really is, in my estimation, right? I mean, you can do more stuff, but all of this is basically theater, right? If you have your own security department and you maintain a 24-hour SOC and CERT and pen tests and ZIEM and whatever, I mean, it has some value, but not if you didn't do the other stuff first. And then you argue it can't get any worse, so let's move to the cloud, and then of course it gets worse in the cloud. You probably saw this, the Microsoft master key leak. So I tried to translate this, but it doesn't work. It basically says, Unmündigkeit means you don't do stuff yourself, but you have to ask others what to do, and then they tell you what to do. And this is Kant, German philosopher, and he said, that's your own doing that you are in this state. And enlightenment means moving out of that state. I think this applies very well to IT security. It's our own doing that we need others to tell us what to do. And we should strive to make our own mind, think about problems, understand them, and then do the obvious thing. How did we get here? Well, if you look at old, not just software, hardware too, like an old calculator, like a tabletop calculator, you see it's made from several parts that do exactly what is needed, and in the end you combine them and you have a product that does what you want it to do. You follow the waterfall model in the design. You know, before you start assembling the product, you know what it's supposed to do in the end. And that means you can have security, because security means making sure it can only do the things you need it to do. And that only works if you know what you need it to do. Right? So, in the old days, the developer had a spec and he knew what the final software was supposed to do. I think we need to get back to that. Because if you do that, you can implement least privilege, like I did in my blog example. Now it's more like, Lego or IKEA. You assemble software from pre-made parts. And those parts are selected by flexibility. In the early days, you took a specialized part that did exactly what you needed to do, because that was cheaper than taking a more universal part. But economy of scale changed that. Now it's actually cheaper to put a little pig or arm chip there. It costs a few cents. It's actually cheaper to do that than take custom parts. So nowadays, it's not just that we don't know what the application is supposed to do in the end, also all the parts are written in a way that they don't know what they will be used for. Because they don't know. They are written to be generic, flexible. So that means all the parts you take to assemble your application, none of them will be least privilege. So if you want to have least privilege in your process, it needs to be in the very end, when it's basically too late. You will be able to do something, it's not impossible, but the best chance would be if the components you use already come with their own little sandbox and self-censoring, basically with Secomp or whatever. That is the promise of microservices. And that part basically evaporated without being seen anywhere in practice. And now it's even worse because we have Agile. And in Agile, it's the premise that even the developer doesn't know, not even the guy paying the developer knows what the final app will be, because that's discovered during the development process. And that means there is no time where you have all the aspects of information you need to implement least privilege. Yeah, I already explained this point. So what do we do now? And I think you know this. We tend to install untrustworthy crap because we think it's the only option we have. Everybody is running Windows and Office and Active Directory, and we have tons of talk on this conference, how to secure Active Directory. And we know it's bad. We know we can't really do it. We still do it because we think we have no other options. And I hope with this talk I was able to tell you that there are options, but they involve some effort. But you have the time. I had the time. You have the time. Just do it. Basically, okay, almost there. Almost there. If you remember nothing else, these are the Google search terms. Remember those. And if you follow these methodologies, your software can actually get better. To me, it's not about the state of the software. There will always be complaints. It's about the trajectory. you have to at least go in the right direction. Doesn't matter if you go very slowly, but you have to go in the right direction. Otherwise, why are we even here, right? So remember those. And now I have some time for questions, I think very little. Thank you.